Let's take another dive back into fictional physics. There's a simple question. How big a wing would a Pegasus need in order to fly? Sans magic. First, the caveats to all mad scientists and wicked witches. Even if you could genetically engineer a horse with wings, that wouldn't be nearly enough. Horses have muscles in all the wrong areas. A bird uses its chest muscles for flight, and a bat uses its hand muscles. But a horse's muscles are all connected to their legs, so you would need an entirely different muscle structure from any other mammal, since, well, there are no six-limbed mammals. Even if you were dedicated enough to build the muscles, then that would throw off our calculations, because this would make your horse much heavier. A bird's chest muscles make up roughly 10 to 20% of their total mass, and they have many adaptations, such as hollow bones, to make them lighter. Additionally, the square cube law is working against you. The short version of this engineering principle is that strength is based off the cross-sectional area. However, weight is based off volume. If you double something in size, it becomes 4 times as strong, but 8 times as heavy. This is why animals have very different shapes based off size. A 1 millimeter ant might be able to carry 100 times its own weight. However, if it was a meter long, the size of a large dog, it would be 1,000,000 times as strong, but 1,000,000,000 times its weight, meaning it would be only able to lift 1/10 of its own weight, and wouldn't even be able to stand up. Finally, I'm an engineer, not a biologist. There is a sizable spread in how effective a wing is based on how the animal flies. The math for biological wings is infinitely more complex than fixed-wing airfoils that we had to do in fluid dynamics. Importantly, biological wings are a lot less effective because you don't have jet engines pushing you along. Fortunately, a lot of the heavy lifting has actually been done for us. I'm basing my math off a 1989 paper from the Journal of African Ornithology. This focuses on raptors. I believe this best represents the agile flight we expected from our flying war steeds. And, well, the wing shape matches artwork. Being optimistic, let's take the bird with the biggest mass load. The Gyps coprotheres, the Cape vulture. It's so big, it's also known as the Cape griffin. That's 1.09 grams per square centimeter. Converting to imperial, this means 2.2 pounds per square foot of wing area. So, now that we know the wing, we need to talk about our horses. I'll go through several Pegasi and do my best to calculate the wing area and wingspan from art and history. I'm going to focus on 3D art, such as statues or computer animation, as painting and traditional animation can be extremely inconsistent in sizing. As far as wing width goes, I'm going to assume a standard wing shape that's proportional by length and width at the base. While I could probably get better results with wings the length of the bat, that wouldn't allow for a rideable mount, which, well, defeats the entire point of this exercise. I'm also going to be fast and loose with rounding, as precise numbers don't matter with this rough quality of inputs. Let's start with the original myth of Pegasus and Bellerophon. Let's use a Greek Andravida breed, which is descended from ancient Greek cavalry horses. They are roughly 14 hands high, or about 56 inches, and weigh a comparatively light 830 pounds. This means that our wings need an area of 370 square feet. From this statue, and assuming a 6-foot Bellerophon, we can estimate a wing width of about 1.75 feet, a wing span of 153 feet, and a wing length of 76 feet. That's just for itself. Assuming that Bellerophon weighs 150 pounds, including weapons and armor, this raises the wing area to 422 square feet, the wingspan to 181 feet, and the wing length to 90 feet. This is just absurd. Insane. That's half again as wide as a 737. I haven't even accounted for the weight of the wings themselves or the muscles needed to use them. But, in the words of Gandalf the White, even this is not the top. Horse 2 is a full medieval knight, with a charger clad in barding plate and a full plate rider. This is used in Warhammer, Fire Emblem, and more than one anime. Let's select an Andalusian, known as the Spanish Horse of Kings. They were often bred and trained as destriers in the High Middle Ages. I had to do some estimates for weight, as I can't find any non-D&D source of the weight of barding armor. As I can't find any realistically proportioned statuary for wing width, let's just extrapolate from that Bellerophon statue from earlier. War horses weren't generally huge mounts, but they stood only 16 hands or so. Going through the math, this Pegasus knight would need a 225-foot wingspan, with each wing being 112 feet long. So since full-size horses keep giving us insane wingspans that just wouldn't work, let's try to have the square cube law work with us for once, by going smaller. Specifically, let's go to little ponies. Unfortunately, this means we're going to have to answer one question. How little are they? There are a few bases we could choose from. Cheese stood in front of a height chart in one episode. People have also calculated this using everything from apples and bunnies or ratioing off the Equestria girls to even a cello. If you want to go old school, you can even use Megan from Generation 1. Each method gets a slightly different answer, but the mares are generally agreed to be somewhere between 3 foot and 4 foot. I'll base my height off 3'6" because we gotta choose something. Basing the rest of the measurements off Zip Storm from Generation 5 and throwing the numbers on the horse weight estimator from thehorse.com, ignoring the don't use a miniature horses warning, gives us a weight of 104 pounds. About the weight of a very large dog, so it makes sense. Unfortunately, because Zip's wings are only 6 inches at their base, the wings are still way too small. Zip's wingspan is roughly 6 foot when fully extended, a tenth of what she would need to fly under her own power. Also, I might remind you, Generation 5 notably increased wing size. To compare, the previous generation has the folded wings stop mid-flank, about at the cutie mark. Generation 5 has the wings extend notably past the rump. These wings are as large as they can be on a horse body. So not only are the My Little Pony wings too small to fly, but they're as big as possible, but only 10% of the needed area. I had considered doing math on the other characters or even pony toys, but realistically, these numbers aren't going to change. It's just too far away from the realm of possibility. Now, for sake of argument, if you do the math for a small filly like Scootaloo, and allow the wings to be the entire length of her back, then we finally have a rational ring size. About the size of Celestia's wings, at 5 foot each. However, I just put the largest wings in the show on the smallest pony in the show. There's no way to tuck that wing in. And don't forget that at every point we estimated in the equine's favor. So, there you have it. Sorry to break the heart of everyone who wants to go on a Pegasus back ride. It's just not going to happen unless you have low gravity, magic, or rocket horses. Though that last one would be a bit awesome. Thanks for listening, y'all.